Okay, so this is, find an infinite sum. When I first looked at it, um, certainly it's a preconceived problem, so certainly you write the problem so it has a solution to it. And something that I would say takes some effort to write the problem, but it takes more effort to solve the problem if you didn't write it. So what I did was I certainly knew what generated the pattern, and then what I did was I wrote a problem for that. Now looking at it, the first thing you notice about there's a 711 in terms, and it looks sort of like geometric except for the coefficients. So I said it was somewhat related to a geometric. I looked at the geometric, wrote that down. It's true when that x is going to be a proper fraction between -1 and 1, and certainly 711 covers that. Then I took a derivative. I got this over here. And the reason I want to get numbers that are getting close to these numbers over here. This takes some playing with it. I'm not seeing it right away. And the next thing I did is to do another derivative. I got this thing over here. Then I started to realize that if I took these three expansions over here and did a manipulation with it, it would certainly take time. I'm not saying it doesn't. Certainly, I knew about it before going into the game, though. All right, but again, it's not a difficult combination. But it turned out to be, this guy here, which is 2 over 1 minus x cubed, minus twice the first one, and then plus the middle one over here. And then I get the coefficients. And then I just plug it in, 7/11, and I got 1397 over 32. And I've always wondered, did I make a mistake somewhere? So one other possibility is to look at the coefficients. That's 1, 6, 13, 22, 33. Take your successive differences, and the first differences you get is 5, 7, 9, 11. And then the next set of difference you get is 2, 2, 2, and that indicating to me that this is quadratic in form. And then you play around with it for a while, and you get a quadratic expression, and the quadratic expression I got was this over here. Now, the reason I want to do that is I want to check my work. I want to see if it really is 1397 over 22. Now, granted, if you want, you can plug in numbers here. For example, 0 would give you 1, and 7/11 to the 0 would give you the first term, which is 1. That's the guy over there. Let me just go to the next term, which is 2. That's going to be 4 plus 8. I'm sorry, I didn't mean 2, I meant 1. 1 plus 4 is 5 plus 1 is 6. I got that coefficient, certainly the 7/11 to the power then. If you try 2, you get 4. Let's see, 8, that's 12, 13. And I think you're probably seeing that over there. And you can check them out if you want. But my goal here was to use Sage to see if actually it's generating the same number I'm getting over here. Mistakes happen. So when I go to the my Sage application, I have it running now. Going to pull this down. And again, I would recommend starting with a reset. And then the next thing is to define n as a variable. And next thing is do the sum. And sum what? And again, I don't think I could have looked at this and knew what the sum was. Right. In fact, I knew there's 7/11, 7/11 squared, cubed, fourth power. It was coefficient, so I did have to work through that. And I did do that, and I got n squared plus 4n plus 1. 7/11 to the nth power from n starts at 0 to infinity. And the big test is to give me the same number. Well, let's check it out. Sage just gave me the number 1397 over 32. So we're in agreement. All right. Thank you.